Welcome back, guys, to this review week. Today is the second day of week 10, the second day of review in math. Tomorrow, we're going to finish with our review. Today, we're going to graph two lines and determine if those two lines are parallel, perpendicular, or neither. Sometimes you're neither. Sometimes you're parallel. Sometimes you're perpendicular. So in this case, we're going to determine if they're parallel or perpendicular. Okay. So we have here a system, let's call it, of equations, okay? We're going to determine first which equation is going to be equation 1 and which equation is going to be equation 2. Just to follow an order, because this one is first, this is equation 1, and this is going to be equation 2. Does it matter the order of those? No, maybe I wanted to do it like that and Camila as well, but maybe Mario and Daniel Enrique wanted to do it the other way around, and that's okay. So probably someone wanted this to be equation 2 for the other exercise that we're going to do, and this to be equation 1. Okay, so there are different ways of finding if two equations are parallel, perpendicular, or neither. Right now, we're going to do it graphically, okay, in order to determine if they are so. So let's begin with equation 1 of the exercise 1. We are going to find out by using the intercept method. Remember, the intercept method is the one that we use for the standard form or for the systems of equations. So that's the method that we're going to use, the intercepts. So we have y equals 3x plus 1. So I'm going to find the intercept in x. And the intercept in x is when y is equal to 0. And I'm looking for the value of x. So I'm going to say 0 instead of y equals to 3x plus 1. So I need to leave the variable x completely alone in one side. So this 3x goes to this side, negative. And we have negative 3x equals to 1. Now I need to leave the variable x completely alone. So this negative 3 goes to the other side. Doing what?
Dividing.
Dividing, very good. And we keep the sign, right? We take the sign with a number. So x is equal to 1 divided by negative 3. And remember that the negative sign could be with the numerator or the denominator or in the middle. So that's what I'm going to do and place it right in the middle. So negative 1/3. For graphing purposes, I'm passing this into a decimal. So this is going to be negative 0.333333333. So I'm going to place a bar, comma, 0. As the intercept in x for equation 1. Let's find the intercept in y. The intercept in y is the other way around when x is 0. And we are looking for y. So we say y is equal to 3 instead of x, 0 plus 1. Anything multiplied by 0 is always 0, so I can cancel that out. So y is equal to 1. And that's the number that I'm placing in there. I found already the intercepts for equation 1. Now we're going to work with equation 2. Equation 2 is 9x minus 3y is equal to 12. And we're also going to find the intercepts, okay? So the intercept in x, just exactly the same like we did in the first equation. It is when y is equal to 0. So we have 9x minus 3 times 0, y 0, equals to 12. 3 times 0 is 0. So I got that 9x is equal to 12. 9 is multiplying, passes to the other side, dividing. So we have that x is equal to 12 over 9. Can I simplify that? Can I simplify that equation? Or most definitely, that is my final answer.
Divide by 3.
And simplified by 3. Very good. So I'm going to divide both parts of my fraction by 3. And we get that x is equal to 12 divided by 3.
4.
4. And 9 divided by 3.
3. 3.
3. So I'm going to place that 4 over 3 over here. And again, just for graphing purposes, I'm going to pass it to a decimal. 4 over 3 is the same thing as saying 1.3333333333, etc. So I'm placing 1.3 with a bar on top, comma, 0. And now the intercept in y, that is when x is 0 and we're looking for y. So we have that 9 times 0 is minus 3y is equal to 12. I'm going to move this a little bit higher so I can finish the exercise over here. 9 times 0, that's 0. So I'm left with negative 3y is equal to 12. Remember, I need to leave the variable y alone in one side. So this negative 3 passes, dividing, and we carry the sign. So y is equal to 12 divided by negative 3. Can I simplify that?
Yes.
By, what is it? 12 divided by negative 3 is how much?
Negative 4.
Negative 4. Very good. And that's the negative 4 that I'm placing over here. And as you can see, I already have my intercepts for both equations. Okay, so let's graph it. I'm going to graph the blue one first. Negative 0.3, 0. Since they're decimals, I decided to use a scale of 2 units of 2 squares per number, per unit. Okay, therefore, I'm going to have 0.3 negative. It's a little bit closer to the 0, but a little bit close to the half. Okay, like there. If this is negative 1, this is negative half. So this is negative 0.3. Okay, you see it's not exactly in the place, but it is an accurate guess. And this is 0.1. I connect those with a straight line passing through the center of both circles. A blue line. I'll do it this other way. Have my graph for the first one. Let's go with the second one. I got 1.3 positive. This is 1. So let's say the 1.3 is around there. And 0, negative 4. Negative 1, negative 2, negative 3, negative 4. I'm going to connect those 2 points with a straight line passing through the center as well. So I have an equation like that. So is this a parallel line? Are this perpendicular lines? Or they're neither? What type of lines do I have? Are they parallel? Are they perpendicular? Or neither?
Parallel.
Those are parallel lines. Very good. Okay. How do I know? Because they have a same slope. Okay. That's how I know. Any other question about this? No? Easy peasy, right? Okay, let's go with the next one. Next one, we decided to make equation 1, the second one, 2x plus y equals to 8. So again, I'm going to find the intercepts for 2x plus y, because that's the method that we're going to be using when we solve parallel or perpendicular lines, even though you can do it with another method, okay? Any questions so far? No questions so far? Okay, so we're going with 2x plus y equals to 8. Intercept in x. What's the intercept in x?
0.
0 is the intercept in x?
2.
Intercept in x. How do I find the intercept in x? When y is 0. Remember that. When y is 0, that's how I find the intercept in x. Okay, so we are going to find the intercept in x. So we have 2x plus y, so instead of y, 0 is equal to 8. This is 0, so I don't need it. So I actually have only 2x is equal to 8. The 2 is multiplying, that's an unequal 8, right? So let's make it pretty 8. That's prettier. 2 is multiplying, it passes.
Divide.
Dividing, very good. So x divided, x is equal to 8 divided by 2. How much is 8 divided by 2?
4.
X is equal to 4. And that's the 4 that I place in there. Now let's find the intercept in y. How do we find the intercept in y?
X is 0.
Well, the x is 0, very good. And I find the value of y. So I'm going to say 2 times 0 plus y is equal to 8. 2 times 0 is 0. So I have that y is equal to 8. And I place that 8 over here. Now we go with the second equation, which is actually the first one. It doesn't matter. Okay, equation 2. Y is equal to 1/2 x plus 8. Again, we find the intercept in x. And the intercept in x is when y is 0. So we're going to have 0 is equal to 1/2 x plus 8. I'm passing the variable with its coefficient to the other side. Subtract them. So I have negative 1/2 x is equal to 8. Now remember, when we have a fraction that's multiplying, it has to go to the other side. How? How does it go to the other side? When it is a fraction that's multiplying. Go to the other side. It is a fraction that is multiplying. How do I pass that fraction that's multiplying to the other side? Remember the little trick, little tip that I gave you? It continues to multiply. It is the only case where I'm not going to have an inverse operation, but I'm going to flip the equation. Very good. So I'm going to flip the fraction of the equation, sorry, the fraction. So I'm having x is equal to 8 times, instead of negative 1/2. There's a mistake in here. It is not plus 8, it's plus 3. You see? None of you noticed that mistake. This is plus 3. But we still have the fraction correct. So instead of negative 1/2, I'm placing negative 2/1. And remember what I told you, it doesn't matter where the negative sign x is, because it is exactly the same. If it's in the numerator, if it's in the denominator, or if it's in the middle, it's still the same thing. So 3 times negative 2.
-6.
Negative 6 over 1. Do I need that 1 as a denominator? No, so I don't write it. I write here the -6. Now I'm going to find the intercept in y. And that is when x is 0. And since we don't have more space, I'm going to move this higher. Okay, so we're going to say x is 0. So y is equal to 1/2 times 0 plus 3. And anything multiplied by 0 is always 0, so it gets eliminated. So y is equal to 3. And we're done with the intercepts. So now we can graph. Let's graph the green one first. We got -6 on the x, comma 0. 1, 2, 3, 4, 5, 6. -6, comma 0. And then 0, comma 3. 1, 2, 3. I connect those two lines with a straight, those 2 points with a straight line, passing through the center. And now I'm going to graph the blue one. Okay, so we have 4, comma 0, 1, 2, 3, 4. And we have 0, comma 8. 1, 2, 3, 4, 5, 6, 7, 8. I also connect those 2 points with a straight line, passing through the center of those points. What type of lines are this? What type of lines are this?
Perpendicular.
Perpendicular. How do we know that they are actually perpendicular? How do we know that they are actually having a 90-degree angle in between them? How do we know that? Okay, so because this appears to be 90 degrees, right? Right? So for this one, yes, they are perpendicular, but how do we actually know that they are perpendicular? Because we have equations and formulas that let us know if a line is parallel or perpendicular. If two lines are parallel, we are going to have that the slope 1 is equal to the slope 2. And if those lines are perpendicular, we are going to have the product between slope 1 times the product of slope 2 are going to give you -1 because they're negative reciprocals, okay? So just let's make sure about this. This is 1/2. Let's call this slope 1. This slope 1 is 1/2. If I transform this, I'm going to have y equals 8 minus 2x. So the slope 2 in here is going to be -2. If is m1 equal to m2? No, right? They're not equal, so they're not parallel. So if I multiply them, if I multiply 1/2 times -2, I have 1 times -2, that's -2 over the denominator. -2 over 2, that's -1. So they are actually perpendicular lines. This is correct. This is what we're going to see tomorrow in our review. Do you have any questions about this part of the topic? No question. Clear as water. You're going to get all of the points in those exercises of your exam. Okay, then this is the review for today.
Miss,
Yes,
¿podría mostrar el primer ejercicio, por favor?
English.
Can you show the first exercise?
Yes, of course. This is the first example. If we did this, you are going to see that M1 is equal to M2. So you can try it at home, but we're going to see it tomorrow as well. So that's it, guys, for today.